plus x squared?
Over 1 plus x squared.
You're tricky. You're very tricky.
And then divide that, or I mean, not divide it, but separate that out into 1 over 1 plus x squared.
So you want me to split this into separate pieces, but not 3 pieces. You want me to actually go and just do 2 pieces.
Yes.
You want me to go 1 over 1 plus x squared plus 1 plus x squared over 1 plus x squared?
Yes.
Which is just 1. Wow. And the antiderivative of this is arctan. The antiderivative of that is x. That works. Good. Now, that's not the way that I would have expected someone to see it. And I wouldn't expect you to necessarily see that. But now you know that's fair game, right? Now you've seen that sort of thing. That worked, right? Okay. I still want to try and get there from here.
That's probably the way most people do it.
Shall I finish this? So capital F of x would be arctan x, because that's the antiderivative of this, plus the antiderivative of this, which is just x, and then plus c. Okay. So that should be the right answer. That's clever. That may not always work, though. Like, we may not always be able to break that 2 up. So let's investigate possibly a different method that would still get us to the same answer.
Substitution.
We haven't done substitution yet. All right, so in the effort to save us a little bit of time, let me do this. Can I erase this side? Anyone need this still? You good? You sure? Sure?
I'm good.
No, I'm looking over you here. Okay. All right. So the problem here, where we were on this one, this was all good, right? This one was some trouble. So let's investigate that. You're not going to like this. Do you know what I'm about to do?
No.
Long division. That's what that is, right? Okay. So if I do this long division, I ask myself, what do I multiply x squared by to get x squared? Just 1, right? Just 1. So I put 1 here, then I multiply 1 times this, put it underneath. 1 times this, that's 1. And then you come through and you subtract, right? Which really just winds up changing the signs of what's here. So this becomes minus, and this plus becomes minus, right? And then you add down. And what would you get? Nothing here, you get -1 there, right? Y'all still with me? Now, x squared plus 1 does not go into -1. So this is our remainder. So the proper way to write this answer is that it should be 1 plus the remainder over the divisor. What's the divisor? X squared plus 1. I'll write it as 1 plus x squared so it looks a little more familiar to you. Y'all okay with this long division? So that right here, this right here, all that, that's this piece right there. So I'm going to put here plus, 1? And then isn't this really a minus because I can drop that negative out? Minus 1 over 1 plus x squared. Yeah. Can you find the antiderivative of this? What would this be? Antiderivative. 2 arctan x. What's the antiderivative of 1? X. What's the antiderivative of this? Arctan x. So you'd have 2 arctan x's. You would take away 1 arctan x, and that would leave you with just an arctan x. Or, at this point, you could realize you have 2 of these minus 1 of those, and before you take the antiderivative, put those 2 together. That would just give you 1, wouldn't it? 1 of them? And now take the antiderivative, and you get exactly the same thing. Arctan x plus c. See it? Arctan x plus c. Now that we kind of know this, I'll leave it to you if you want to try it yourself. You can actually do this problem with long division right off the top, like right from the start. Just do long division on that. And we're actually going to have a section in this class towards the end. It's called a section on what are called partial fractions. And I think in pre-cal you did something called partial fraction decomposition. I don't know if you remember that. How many of you remember that from pre-cal? think it was in the beginning of the class. It's called partial fractions. And the reason you did that is because in this class we're going to need it. And the first step for partial fraction decomposition is to look at your rational function. And if they're the same degree, which these are, you do long division first. That's the first step. So if we were doing this problem later on, we would have a process for it. But because it's not later on, we could only rely on what we know right now. And so we saw two ways of doing it. One used long division. The other one was a clever way of rewriting it, right? 1 plus 1 instead of 2. All right. There it is. All right, let's talk about motion in a straight line. So let's see, when you were in Cal 1, I hope that you did talk about motion of objects that travel in a straight line. And specifically in Cal 1, you should have discussed that if you have a function that represents the position of an object, so let's call that function s, which is f of t. So it's basically a function that if you graph it, here's time, here's s, and you can measure this maybe in like hours, and maybe you measure this in like miles. And then if you draw the graph, whatever it is, then at every point in time, you know exactly how far the object has gone. So this would be a position function. If we take the derivative of that, we get a new function, right? And that new function would be the velocity function. And it would tell us the speed of the object at every point in time. And if we took the derivative again, the second derivative of this original function, that would be the acceleration function. And that would tell us the acceleration at every point in time. That sound familiar to you? No? Okay. Well, in this class, what we want to do is we want to be able to work the opposite way. So if somebody gives us an acceleration function, we want to be able to go all the way back and recover the position function from the acceleration function. All right? And let's discuss that for a second, because I've always found this to be one of the more profound ideas. What are, if I'm telling you about an object that's moving, and I'm telling you something about its acceleration at every point in time, do you think that you can actually then tell me where it is at every point in time? What do you think? So think about the other way. If I tell you exactly where something is at every point in time, where it is, position, then do you think it's reasonable to be able to figure out its speed at every point in time? That seem reasonable to you? And then from that, you should be able to figure out the acceleration? So that seems reasonable. Knowing where something it is at every point in time is a lot of information to have, isn't it? And you can get a lot from that. But I'm asking you to think about it the other way. If all you know is its acceleration at every point in time, do you think it's possible to actually recover where it was in physical space? You need to know more than just the acceleration, right? There's something else you're going to need. It's to go backwards. Each time you go backwards, you have that plus c, don't you? And that gives you a family of functions. And so you don't know which one it is. So how are you actually going to get back to the specific position function if you don't even know what the velocity would have been? Make sense? But what we need to know is minimal. It turns out that we don't need to know much. So this example here will get us going. Yeah, let's just do this easy one first. All right, here we go. We have the acceleration of a function is given to us, all right? And we're not given any units here. So if this were like in some physics class, the acceleration might be measured in like meters per second or something like that. But we're just writing it as just a general function, 24t minus 6. That's our acceleration function. What does s of, this is a 1. So my other class thought that was an I, but it's a 1. What does s of 1 equals 7 and v of 2 equals 41, what does it mean? Because this is all given to us, okay? This is all given to us in the very beginning.
That's the position at time 1.
Okay, at time 1, this is its position.
Yeah, and that's the velocity at time 2.
Exactly. At time 2, this is the speed of the object. All right, velocity. Yes? Are speed and velocity the same thing?
No.
In linear motion, they are. In linear motion, straight line motion, speed and velocity are the same thing. But if your object is moving in 2-dimensional space or 3-dimensional space, then velocity and speed are not the same. All right, so here, if I say speed and velocity, it's because I can say that for linear motion. All right, so according to this information, you're given the acceleration, you're given one piece of information about its velocity, one piece of information about its position, and from that we should be able to recover it. So I want you to think about this visually. If this is the graph, let's say this is the graph of the acceleration function, right? When I find the antiderivative, it gives me a family of functions, doesn't it? So maybe I look at the velocity here. I know that it could be a bunch of different curves, but they all look kind of the same, right? This is a terrible drawing, but they all look kind of the same, yes? But the fact that they tell me v of 2 is 41, only one of these graphs is going to contain that point. Only one will contain it. So I go out here, I say v of 2 is 41. Ah, it's got to be that one. So now I know it's that particular function, and I can chunk the rest of them. I know it's none of these, right? And then from that, I find the antiderivative, and that takes me back to the position function, doesn't it? I'll call it s of t. All right, position function. That gives me a family of functions again, whatever they look like. And then I have something about its position at 1 at 7. So at 1 at 7, and there, it's that one. And so I've nailed down the exact position function. Does that make sense visually? That's what's going on. But now we need to see how it all unfolds algebraically. All right, so let's start out with just first finding the antiderivative. Oh, so we want to find the position function. Once we find the position function, we want to know the actual position of the object at time 2. We know the position of the object at time 1, but we want the position at time 2. So here we go. So tell me about the velocity function. The velocity function should be the antiderivative of the acceleration. So what's the antiderivative of that?
12t squared minus 6x.
12t squared minus 6t. You said x, but yes, I understand what you meant. So all I'm doing is the power rule on that, right? The 24 came for the ride, and then I did 1 over 2t squared. So I did the power rule on that piece right there. That gave me this. And then the antiderivative of a constant is what? What's the antiderivative of any constant? The same constant times whatever the variable is. So if you say, what's the antiderivative of pi? You would say pi x. Or if it was t, you'd say pi t. Or if you say, pi r, whatever the variable is. That good? Plus c. Don't forget the plus c. All right? So here's what I know. I know that the velocity function is one of those functions. It's a family of parabolas, isn't it? Which parabola is it? Well, my goal here now is to find c, right? I need to find c. But I know that v of 2 equals 41, which means that when I'm looking at this velocity function, if I plug 2 in for t, it must spit out the value 41, right? So let's plug 2 into this and see how we could get 41. So v of 2, I get 12 times 2 squared minus 6 times 2 plus c, that needs to be 41, right? And if you look at that equation, it only has one variable in it now, and it's c, and that's what we wanted, right? So this is what we call, I think, sir, you said initial condition, right, or something like that? So usually when we say initial condition, it's like we usually use like time is 0. But if it's not the actual initial, then we just call it a condition. It's just a condition that we have. Okay, so we solved this. 4 is 48, right? Minus 12 plus c equals 41. And this is just arithmetic here. 36 plus c equals 41. And then subtract 36 from both sides, you get c is 5. Right? So that means I've nailed the velocity function down exactly. V of t is 12t squared minus 6t plus 5. I have been able to go into that family of functions and pick out the exact one that we're talking about. And so now I need to go back to the position, right? So I'm going to do the same process over again. So to get position function s of t, does anyone have any questions? Y'all are awfully quiet. I mean, I feel like y'all are paying attention, but I'm not really getting any feedback. Are y'all all right with this? Is this too easy? Should we just skip it and just move on?
Skip it, but then keep on going.
Okay. We're just, this is the calm before the storm. All right, we're just enjoying the relaxing feeling that we have right now. It's not that bad. Antiderivative, what do we got? 4t cubed minus 3t squared plus 5t plus c. Now here's my recommendation. If you're ever going to go back twice, okay, like from acceleration to velocity and velocity to position, or if you're ever going to go from, sometimes you'll be asked in your homework to go from f prime all the way to f. That means you got to go from f double prime to f. That means you got to go from f double prime to f prime first, and then f prime to f. So if you're ever going to go 2 steps of antiderivatives, I recommend on the first step use plus c, and on the second antiderivative use plus d, capital D. That's usually the rule of thumb that we use. And that's just so we don't confuse the c. If we call this c and that c, then you're saying c is 2 different things, and it's just, it can be a mess. Is that all right? All right. So I need to find d now, right? But what do I know? S of 1 is 7. And that means if I replace all these with 1s, all the t's with 1s, I should get 7. So this should be pretty easy to plug in, right? Because 1 to any power is just 1, so right? So this is 4 minus 3 plus 5 plus d equals 7. I think you can handle it from there. Did I do that right? D is 1? D is 1. So I think I'm ready to answer part A. Part A said, what's the position function, right? So to answer part A, my position function is s of t equals 4t cubed minus 3t squared plus 5t and then plus 1. Does everyone agree with d is 1? Like right around here I stopped paying attention. Are y'all, yes? Y'all good with that? Okay. If I make like some ridiculous arithmetic error like